So in this video, we're going to talk about linear equations in two variables. And on the screen right now, I have ax plus by equals c, where a, b, and c are already known, and my variables are x and y. This is called a linear equation for a number of reasons. If we're to plot all the solutions, and there's an infinite number of solutions, talk about that in a second, they form a line, a straight line. Also, if you look at the exponents on the variables, if we don't see anything written there, we assume that they're ones. And linear equations have an exponent of 1. Again, there's an infinite number of solutions. And these solutions take on the form of ordered pairs or points that look like x comma y, where we have an x value and a y value, and the order matters. So let's just jump in. Let's consider 2x plus 4y is 12. So we can verify that the point 2, 2 is the solution. So let's verify. Is a solution. So my x value is 2 and my y value is 2. So I'm going to replace the x with 2 and then the y with 2. We really can't confuse this one too much. 2 times 2 plus 4 times 2 is what? Let's see. 4 plus 8. This is just an order of operations problem now. That gives me 12, which is what the equation should be, or what the equation had. So if I plug in 2 and 2, I get 12, and that's exactly what we want. Now, we can try to plug in some other values. Let's say 5, -2. Is that a solution? Well, let's try. 2 times 5 plus 4 times -2 is 10 plus -8. And 10 plus a -8 is 2. That is not 12. So no, that is not a solution. So 2, 2 is a solution, and 5 -2 is not. So I want you on your own to verify that the following 2 points are solutions. Let's look at 0, 3 and 6, 0. Fix my 3 there. So go ahead and pause it and plug each one in. Plug in 0, 3 first, and then 6, 0 on the, redo it with 6, 0, and verify that those are both solutions and they both work. So, like I said, that these points form a straight line if we were to graph them, and we talked about graphing in the previous video. So let me rewrite everything here. You don't have to rewrite all this, but I want everything on the same screen. So we're looking at 2x plus 4y is 12. And we mentioned that, let's see here, 2, 2. And get that to cooperate. 0, 3, and 6, 0 are solutions. So let's go ahead and graph those. So what I'm going to do is I'm going to draw my Cartesian plane. I'm going to be careful. So it's going to take me a moment, and it should take you a moment too, if you're hand drawing. I like to make sure that my axes are perpendicular, forming a nice 90-degree angle. When I draw my tick marks, if I draw any, I don't like to make them very big because I don't want them to detract from my picture. I make them evenly spaced out, and since I have these grid lines, it's very convenient. Some students like to buy graph paper for this. That's optional. You don't have to, but it's not a bad idea. And I make sure I label my axes X and Y. So let's plot some values here. 2, 2 is up in quadrant 1. And 6, 0, 1, 2, 3, 4, 5, 6, and 0, 3 are both on axes. All right, so normally I like to use a straight edge. I'm gonna have to wing it here because my tablet does not like me messing with straight edges. So let's see if I can draw a nice straight line. I want to try to make my lines go edge to edge. We can label our points for completeness. And remember the X comes first and the Y comes second in ordered pairs. All right. What point did we say didn't work? Was that 5, -2? Yeah, let's look at 5, -2. So 5, -2. Where is 5, -2 at? So I go out to 5 and down to -2. Hey, that point exists on the graph or on the XY plane, but it doesn't touch the line. So it's not a solution. So that's kind of a visual of what's going on. So when we're doing our homework or working on math in general, a lot of times you're going to be asked to graph a line by generating points. And when you're in standard form, which is this ax plus by equals c, that can actually be pretty challenging to generate more than a couple points. And it feels like you're guessing. So what we're going to do is we're going to try something else. So if we're told to graph 3x minus 5y equals 15 by plotting 3 points, we're going to do a little trick here. What we're going to do is we're going to solve for y. And we're going to get this in form of y equals something. So let's do that, and I'll talk about why that's important. And then we'll go ahead and generate the points and graph. Okay. So my first step, let's rewrite the problem. 3x minus 5y is 15. And since I want to get y by itself, I want to get this 3x over on the other side. And I'm going to do that by subtracting. So if I subtract 3x from both sides, I can add the opposite. And that means I can stick it wherever I want because addition commutes. So negative 3x and 3x cancels out. I get a negative 5y and negative 3x plus 15. That negative sign stays there, even though the three x's cancel out. That negative sign stays there. Now I have one more step to complete. I have to divide everything by -5 to get my y by itself. So -5y over -5 is -3x over -5 plus 15 over -5. Cleaning everything up, I'm going to get y equals 3/5 x minus 3, paying attention to my signs, and simplifying my fraction. So now I have this equation. There's a special name for this that we're going to learn about later. And we're not going to worry about it now. For the time being, though, we're going to talk about dependent and independent variables. So we say that y depends on x. So if you can write something as y equals, and then everything has x's on the other side and y is by itself on the other, we can say that y is the dependent variable and x is the independent variable. That means x calls the shots. So I get to pick values to plug in here. And when I pick my values, I plug them in and I do the order of operations and I get y values just by doing the math, the arithmetic. So for starters, let's talk about some values to plug in. If I plug in 0 for x, that fraction goes away. So x equals 0, that gives me y equals 3/5 times 0 minus 3. And that's 0 minus 3, so it's -3. So I got y equals -3. So if x equals 0, y equals -3, and that gives me 0, -3 for a point. If I were to plug in something like 1, then I'm gonna have to deal with a fraction here because 3/5 times 1 is 3/5. That's not very helpful. I'd rather not graph fractions. Sometimes we have to, but we can avoid it. And so one of the reasons why I like getting y by itself is I can look at the number in front of x. And if it's a fraction, I look at the denominator, and that's going to give me a hint at what kind of numbers would be good to plug in. If I can plug in multiples of 5, this whole thing would simplify because the multiples of 5 would cancel out with the 5 in the denominator, and I just get something times 3 up here. Okay, so let's take a look. Let me try. Well, why don't we just try x equals 5? So I plug in x equals 5. What does that give me? Y equals 3/5 times, well, 5 is just 5 over 1 if I need to think about it that way. Sometimes that's helpful. So I got y equals 3/5 times 5 over 1, and then minus 3. Well, the 5's cancel out, and I'm just going to get 3, and it's 3 over 1, or just 3, minus 3, and that's 0. That's pretty cool. So if x is 5, y is equal to 0. So 5, 0 is a point. I have two of my points. I have 0, -3, and I have 5, 0. We need to find another point. In order to find another point, again, we're looking at y equals 3/5 x minus 5. Let's try to plug something in that's a multiple of 5. Let's go the other way. Let's try x equals -5. Okay. Y equals 3/5 times -5 over 1 minus 3. The 5's cancel out, but that negative sign's still there, so it's a -3 minus 3, and that gives me -6. So x is -6, x is -5, y is -6. So I have 3 points. There's a way that we like to organize these, and you might remember this from a previous math class. We call it an XY chart or table or a T table. And what did we plug in here? We plugged in 0, 5, and -5. And I like to put my x's in order. You don't have to, but my x column, that's going to be ascending as a, well, the numbers are going to go from more negative to more positive as I go down the chart. And the numbers that I get for my y are just going to follow what I got from my calculations. And some people like having an extra column there for the points. And this is all a lot of, I mean, we can consider this optional, but almost every student I have uses this way of organizing things, and it really helps keep things in order. Okay, so I need to graph this, and I have some room. So x, y, 1, 2, 3, 4, 5, 6, 6. And if I go to -5, -6, I go to 0, -3, and I go to 5, 0. And hey, look, those are lining up in a straight line. And I get to connect my dots. And that is how I would graph a line. And we will talk about some important parts of the line, namely slope and the intercepts in the next video.